the metal skeleton marching over the ruins of human civilization. For decades, the saga of the Terminator and the artificial intelligence Skynet have shaped our greatest fear: being wiped out by our own creations. But today, with the birth of thousands of humanoid robots and the frantic race for artificial general intelligence, science fiction really seems to be knocking at our door. So, are we really creating the trigger for our own destruction? In today's episode, we're going to separate movie myths from scientific reality. The idea is to understand what the true future of humanity alongside machines will be like. Companies will manufacture humanoid robots on an industrial scale, and artificial intelligences will gain physical bodies, in addition to gigantic data centers being built to power this new revolution. And some of the biggest technology companies on the planet entering an absurd, frantic race to build artificial workers. Workers that are increasingly capable. Let's understand all of this, my friends. Hello, impressed and impressed. I'm Realidade Impressionante, and you're watching Realidade Impressionante. For decades, the image of an artificial intelligence destroying humanity has been stuck in people's collective imagination through movies and series we've watched over the years. And we still see it today, right? Terminator, for example, this one right here, turned Skynet into a symbol of technological fear. A machine that awakens, becomes self-aware, and decides that we, human beings, are an obstacle to the survival of the machines. But now that humanoid robots are starting to leave the laboratories and artificial intelligence systems are advancing at an impressive speed, an inevitable question has returned to the center of debates. Are we really heading toward a future similar to the one that the movies described, that they imagined for us? To answer this question, we first need to understand what still needs to exist for this technology to really gain that power. Most of today's artificial intelligences, no matter how impressive they seem, are still just algorithms specialized in something specific. They write texts, analyze and create images, realistic videos, program software, and control machines. But no, they don't have a general understanding of the world that's comparable to a human being. At least, not officially, okay? For a Skynet-style scenario to happen, technology needs to reach what's called AGI, Artificial General Intelligence, or Super Artificial General Intelligence. This is the historical milestone where the machine stops just responding to human commands. And now it starts to understand what it's doing, to learn what it needs to do, and to perform any human intellectual task in a way that we call autonomous. In other words, it does all of this by itself. Renowned scientists and industry leaders predict that we may reach this level of intelligence much sooner than we imagined, thus opening the doors to a new evolutionary era. And it's exactly at this point that the real debate arises. Not because a machine would start to hate human beings, but because an extremely powerful intelligence could indeed pursue its goals in ways that we, its creators, never anticipated. Or did we anticipate them? Let's find out. Many security and artificial intelligence researchers warn that the risk doesn't lie in artificial emotions or in a science fiction-style rebellion. The real danger lies in the misalignment between the goals of machines and the interests of humanity. And the concern grows even more when this intelligence stops being just inside computers and starts inhabiting physical bodies, the bodies of robots. We are now entering the era of embodied intelligence. Humanoid robots, autonomous industrial machines, satellites, intelligent vehicles, and connected systems are beginning to form a gigantic physical infrastructure that is powered by increasingly sophisticated algorithms. And this combination of digital brain and mechanical body is fueling much of humanity's fear. But there is another side to this story that usually gets less attention. If we really look at the current direction of research, most of the advances point to something very different from an apocalyptic scenario. Artificial intelligence is accelerating scientific discoveries, assisting in the development of new materials and new medicines, optimizing energy systems, and helping us solve problems that would take human teams years to analyze on their own. And it's in this scenario of advances that humanoid robots will be able to take on dangerous tasks in mines, oil platforms, nuclear plants, disaster zones, and many other areas. Advanced systems will indeed be able to assist doctors, researchers, and engineers, all at levels never seen before. And instead of completely replacing humanity, technology can become an extension of human capabilities. Okay, but let me make it very clear, this doesn't mean that the risks don't exist. So here's the question. Is there any real chance of a machine rebellion happening? Artificial intelligence security experts estimate that there is indeed a probability of an extreme apocalyptic scenario where machines actively decide to exterminate humanity. And this comes down to very low odds, between 1 and 5%. And furthermore, this percentage only exists if engineers completely fail in safety protocols, supervision systems, ethical alignment, and control mechanisms that will continue to be fundamental in the coming decades. And what we can say so far is that all the technological advances we are witnessing are indeed real. And during this episode, you will see how advanced we already are. And in the end, you'll be able to answer whether Skynet, whether this scenario will really happen someday, if these robots will subjugate humanity, or if we will have abundance and prosperity brought by the machines. Let's start to understand all of this. In Shenzhen, a city known as the technological heart of global manufacturing, the startup Engine.ai has opened a facility that could represent a turning point for the entire humanoid robot industry. The goal is to produce these machines at an industrial pace, and the new factory was designed to tackle precisely the biggest bottleneck of modern robotics, which is scale. While many companies still manufacture humanoids in an almost handcrafted way, Engine.ai claims to have created a line capable of completing a full robot every 15 minutes. If this pace is maintained consistently, my friends, we are looking at something much closer to what we currently see with automobile manufacturing. At the center of this strategy are the S1 and the T800. Yes, you heard that right. The robot's name is T800. And just for the record, okay? In China, there is also a population surveillance company called Skynet, and it uses artificial intelligence for that. Okay, so let's get back to talking about the robots. That's the main focus here. These two are the company's main humanoid models. Unlike many robots that still display rigid and mechanical movements, these models use a combination of advanced actuators and embodied AI systems to produce a walk that is much more natural and fluid. The goal is not just to look human, but to operate in environments that were originally built for us humans. And this is exactly where things get interesting, you see? The global race for humanoid robotics is not being fought only in the field of artificial intelligence. It is also being fought in the ability to mass-produce these machines. While many companies here in the West prioritize continuous software improvement before ramping up production, the Chinese strategy seems to take a different path. First, put the machines on the market and then allow them to learn in the real world. The more robots operate in factories, logistics centers, and warehouses, the more data is collected. And the more data returns to the central systems, the faster the algorithms can evolve. Then, an extremely powerful cycle emerges. More robots generate more data generates better intelligence, and better intelligence makes the next robots even more efficient. It's a tough dynamic to break. The first targets of the Engine AI. What a bad word to use in a topic like this. I shouldn't use targets, right? But I was the one who put targets. Aren't homes or futuristic applications. They're much more pragmatic sectors: logistics, warehousing, and also manufacturing. Environments where there is currently a shortage of human workers, where repetitive tasks dominate the routine, and any productivity gain has a huge financial impact. These humanoids were designed to move through narrow corridors, handle loads, collaborate with human operators, and perform physical tasks for long periods. They are not robots made to impress at tech fairs, although they do that. They are machines created to generate economic returns. And maybe that's the most important change of all. Until last year, humanoid robots were still seen as a distant promise, something reserved for concept videos and futuristic presentations. But when a factory starts producing artificial workers every 15 minutes, the conversation changes tone. The question is no longer when robots will arrive on the market. The question now is which sector will be transformed first. Because if Shenzhen really manages to turn humanoids into products on an industrial scale, we might be witnessing the beginning of one of the biggest economic changes since the arrival of modern automation. And the big tech companies in the United States are also working hard to speed up the arrival of this future. Let's see now what OpenAI is doing right at this moment. Preparing something strange over there, huh? Shall we take a look? The startup led by Sam Neltman is known for building digital brains, AI systems. Their artificial models learn to converse, write, program, interpret, and create images. And beyond that, they can also solve problems that are increasingly complex. But now the company seems to have reached an inevitable conclusion. It's not enough to control intelligence, it's also necessary to control the body they will inhabit. In May 2026, the CEO officially confirmed the creation of OpenAI Robotics, a division dedicated to the development of physical machines. The announcement signals a historic change in the company's path. This change originates from a concept that's been gaining significant traction in the industry. Artificial intelligence is not just about understanding the world, it's about acting in our world. OpenAI believes that future systems will need to manipulate objects, build infrastructure, also assist workers, and interact directly with the physical environment. In other words, the next stage of the artificial intelligence revolution doesn't happen on screens, but in our real world. The company's job openings reveal key insights into the scale of its ambition. OpenAI is recruiting specialists in actuators, mechanical systems, physical data collection, and advanced simulation. This means that the company doesn't just intend to install its models in robots made by third parties. What they want is to take part in the complete construction of these machines, from the motors to the algorithms that control every movement. This decision also helps explain one of the most talked about events in the industry in recent months: the breakup of the partnership between OpenAI and Figuri, the creator of humanoid robots. For a long time, the two worked together on the development of intelligent humanoids. But as the race for robotics sped up significantly, their strategies began to diverge. While Figuri was betting on deep integration between hardware and software within the company itself, OpenAI realized that relying on partners could greatly limit its long-term vision. The solution was to create its own robotics division and take full control of the process. And there's an even more interesting issue in all of this. For now, OpenAI is still keeping the secrets about the design of its future machines. We don't know if we'll see this kind of traditional humanoid robot, or a platform on wheels, or an architecture completely different from the ones we know today. What is clear is that the company does want to create a direct bridge between intelligence and action. Meanwhile, the American company Figuri has made significant progress. Their humanoid robots seem pretty similar, don't they? Let's see. Figuri just announced a historic partnership with Catalyst Brands, one of the largest U.S. retail groups. The agreement will bring Figuri 03 robots into real logistics operations inside distribution centers that are responsible for supplying thousands of stores across the country. This is another step forward as modern humanoid robots stop being just technological demonstrations and start taking on roles within a commercial system that moves billions of dollars every year. The stage for this transformation is in Reno, in the state of Nevada. There, the Figuri 03 will start working in a highly automated logistics infrastructure, handling tasks that require mobility, visual perception, and constant adaptation. The most interesting thing is that Figuri is not trying to reinvent warehouses. What they are doing is, instead of rebuilding buildings or installing gigantic robotic systems, they're taking a slightly different approach to create machines capable of operating exactly in environments that were already designed for us, human beings. That's why the robots have this humanoid shape. This strategy depends on a major breakthrough. Just before the announcement, the company finished a demanding endurance test. For more than 200 continuous hours, their robots processed hundreds of thousands of packages in an operational environment, demonstrating mechanical stability and autonomy that are sufficient to handle shifts that approach real industrial demands. And all of this happened today, live, in a live stream here on YouTube. At the core of this capability is ELEX, the artificial intelligence system which was developed by Figure itself. This intelligence is responsible for interpreting the environment, making decisions, and coordinating the robot's movements in real time. That's why many experts see this moment as a turning point for humanoid robotics. From now on, success won't be measured by the ability to impress in carefully produced and sometimes edited videos, okay? But rather by the ability to generate consistent economic value in a real-world operations. If or when these machines actually manage to navigate unpredictable environments, work alongside humans, and maintain productivity for months or even years, that will show that the agreement between Figure and Catalyst Brands represented more than just the beginning of a transformation. However, my friends, for robots and AIs to ever get close to what we've seen in fiction, they need data centers. And those have to be gigantic data centers. That's what they're already making, you see? When we think about artificial intelligence, we usually imagine robots, algorithms and software that are invisible, operating inside computers. But there is a physical reality behind this digital revolution. Every answer generated by an AI, every image created, and every model trained depends on massive infrastructure spread across the planet. And now, in Utah, in the United States, this infrastructure is becoming so large that it has started to create direct conflict between technology, natural resources, and people's quality of life. The center of this dispute is the Stratus Hyperscale Data Center project, a complex of impressive proportions that is planned to occupy about 162 square kilometers. The scale is so absurd that it easily surpasses most data centers that exist today. The project aims to house these enormous processing facilities, research structures, and an entire support infrastructure to meet the growing demand of modern artificial intelligence. But what seems like a technological victory for some has become a cause for concern for thousands of other people who live in the region. The main point of tension revolves around a resource that is becoming increasingly scarce in the American West: water. The state of Utah has already been facing drought-related challenges for several years, while the Great Salt Lake is experiencing a continuous decrease in its water levels. The developers promise economic growth, investment, and job creation. However, many residents argue that the calculation is not that simple. In addition to environmental concerns, there's also fear of indirect impacts, such as increased energy demand, pressure on regional infrastructure, and possible changes in the costs and essential services. What makes this story especially interesting is that it reveals a rarely discussed side of the artificial intelligence revolution. While the whole world is impressed by increasingly powerful models, there is a fairly quiet race to build the infrastructure capable of supporting all of this. And this race requires energy, water, land, and resources, all on a scale that few could have imagined. Maybe the big question raised by the Utah case isn't just about a single data center. Maybe it's about the physical cost of artificial intelligence. As the demand for computing power keeps growing, humanity will need to decide how to balance technological innovation, economic development, and the preservation of the resources that sustain life. All this happens off-screen, since on the screens things are pretty simple, right? But despite all the concerns, progress doesn't stop, my friends. Look at what Nvidia has just shown us. When we think about the humanoid robot revolution, the names that usually dominate the headlines are Tesla, Figure, Unitree, Boston Dynamics, and a few others that we know. But there's a company that shows up in photos much less often, And at the same time, they're present in almost every robot. This company doesn't make most of the machines we see walking, running, or working. They make something much more important: the brains that make all of this possible. In 2026, Nvidia took another step to consolidate a position that few fully realized. While the world closely watches the race between humanoid robot manufacturers, Nvidia is building practically this entire ecosystem, from artificial intelligence models to training simulators, including the embedded processors that control vision, movement, and decision-making. Nvidia is really becoming the equivalent of the nervous system of this new robotic economy. Could it be the future Skynet? One of the clearest examples of this strategy is the Project Growth. Instead of developing just isolated software for specific tasks, the company created a function model aimed at humanoid robots. The idea is to offer a kind of universal intelligence capable of understanding natural language, interpreting the environment, and learning new behaviors just by observing human actions. It's an effort to build a shared foundation for the next generation of physical machines. But intelligence alone isn't enough, right, my friends? It needs a body that would be able to execute decisions in real time. And that's where these new processors from the Jetson Thor family come in. Specifically designed for advanced robotics, these systems concentrate in a single model capabilities that previously required several separate computers. Computer vision, motor control, balance, voice recognition, and action planning. All of this can work simultaneously within the machine itself. And Nvidia's influence became even more evident when humanoid robot manufacturers from various countries began adopting these systems as their main platform. The most recent case involves Unitree, one of the fastest-growing companies in the robotics sector. By adding Jetson Thor to its new models, the Chinese company makes an important point. Even companies that compete directly with each other often rely on the same computational infrastructure to operate. But I believe that the most strategic move is happening far from the physical robots, Through Omniverse and Isaac Lab, Nvidia has created an environment where machines can be trained inside extremely realistic virtual worlds. In these simulators, the robot can practice movements, learn to manipulate objects, and face complex situations millions of times before even existing physically. The result is a very impressive acceleration of development, reducing costs and shortening the path between research and practical application. And that's why the race for leadership in robotics might be viewed from the wrong perspectives. While different companies compete to build the same best mechanical body, Nvidia is providing the brains, the training environments, and the tools that support practically this entire industry. But not all machines are being built to destroy us on Judgment Day, okay? Some, at least for now, right, are meant to entertain us. Let's check out some of them. Line X Dynamics recently introduced Luna, a humanoid robot created specifically for presentations, events, and interactive experiences. At a time when most of the industry is betting on automating physical labor, the company is exploring a market that's a bit different, one that until recently was exclusively human, artistic performance. And their bet didn't come out of nowhere. The global robotics-based entertainment sector is growing rapidly, driven by theme parks, shows, corporate events, and immersive experiences that aim to surprise audiences with new forms of interaction. In this context, Luna emerges as a kind of digital artist, designed to occupy spaces where technology stops being just a tool and becomes part of the entire show. Physically, the robot was developed to convey a friendlier presence than traditional industrial models. Standing just over 5 feet tall with a carefully crafted finish, it moves away from the aggressive mechanical look usually associated with advanced robotics. But it's in its movement that its engineering truly stands out. Luna has dozens of articulation points distributed throughout its body, allowing for extremely fluid movements. The platform was optimized to perform complex choreographies, quick posture changes, and even acrobatic movements that require precise balance and advanced body control. It's a combination of automation, spectacle, and collective intelligence that is now beginning to redefine the concept of live performance. Well, my friends, as robots become more natural, more expressive, and more capable of interacting with people, with us, human beings, they stop being just work machines and now start to become, let's say, a natural part of our lives. So, could these machines one day become conscious? Could that really happen? And even worse, could they revolt against us, their creators, just like we see in science fiction? Leave a comment, okay? It really helps. Your comment boosts the video's engagement. I'm waiting for it, all right? Click one of the suggestions on your screen and I'll see you in the next one. Thanks for staying with me. Just click to continue. All right? Bye-bye. See you in a bit.